everyone, hi again. Welcome back to the another video of Lead Code Coding series. So to continue our array series, we will solve a new problem that is maximum sum array sum of size k. So in the previous problem, we find that what is the maximum sub array sum. Okay, we don't know what is the size of subarray, and it may be of any size, maybe of size of 3, 4, or depends on the array. But here we have given the size of subarray, and we have to find which subarray is maximum, which subarray sum is maximum of that size k. Also, after solving this problem, you will learn a new technique, that is sliding window technique. So it is a different algorithm, a sliding window concept, you can say that. And there are a lot of problems you can solve with this technique. There are a series of problem on this technique, but here in this series we actually solving array problems. Okay, so why we just introduce sliding window concept, but when we will like discuss the algorithms, there we will discuss a separate playlist. We will make a separate playlist on sliding window, and there we will solve all kind of problems on sliding window technique. So let's start. So what is the problem statement, guys? So here it is given that we have an integer array ARR of size n. Size n, that means the size of array, and also the number k, and that number k is simply it is a sub array size. And what we have to do, we have to return what is the maximum sum of sub array of that size k. So just look at this example one. So we have an the array size n is equal to 4, and the k, that is the sub array size, is equal to 2. And what are the array elements? It's simply 100, 200, 300, and 400. Okay, so just focus that which subarray has maximum sum of size 2. So when we start from beginning, the subarray is 100, 200, or maybe 200, 300, and 300, 400. These are the subarrays of size 2. So here you can see that 700, that is 300 and 400 subarray, which has maximum sum, that is 700. So this is our basically problem. And now where you will find this problem? So you cannot find this problem at lead code. Okay, so it is available on gigs for gigs. So I will put the link of this problem inside the description box, so you can ask me that how can we solve this problem. So the first way of to solve this problem is that brute force algorithm. So it's simple, it's very simple. So how can you solve it in brute force algorithm? Simply you will iterate a one for loop for uh, iterating array, and you use another for loop from 0 to k. Okay, that is for sub arrays. You will check one by one. Suppose for 100, what are the sub arrays made of 100? It's simply 100 and 200. Okay, and then you will just check what is the sum. Okay, you store that, and again you will iterate from like 200 to 300, and here you will just add that this is the sum. So in this way you will iterate each sub array using two for loop. The time complexity of this brute force algorithm is order of n into k. There n is equal to the array size and k is the sub array size. Why? Because you iterate first for loop I is equal to 0, and the termination condition is I less than n minus of k. And the second for loop, basically you will start int j is equal to I, and it's less than I plus of k, the value of j. So why the time complexity of order of n into k? But this is not an efficient solution of this problem. So we will solve this problem in linear time, that is in order of n. So right now, how can we solve this problem in order of n time? Okay, so we will solve this problem in order of n time using this technique, that is a slidey window concept. So this is basically a separate algorithm where you will solve lot of problems. Okay, this is kind of problem on this technique. Since we are solving right now array problems, so we will only solve this maximum subarray sum of size k using this technique. So before solving this problem in order of n time, we have to first understand what is the idea behind this technique. So simply think that this is your array. Okay, so this is basically your array, and their window, yeah, you can understand this is window, the sliding window, a window can slide. So here you can think that this is our window. What is you can simply say, suppose the size of k is 2 here, so I'm just making a window like that. So you can assume that this is your window. and the length of window, you can say that the size of glass is simply the size of k, sub-array size. Okay, and you can slide it, you can slide it forward, or also you can go backward, but here we can solve, since we are solving this problem, so we will slide this window forward only, understand. So you are sliding your window, make sure that you will not break the window. That is basically the problem. That means you cannot slide in this way that the first part go up to 4 and the sorry, the second part goes up to 4 and the first part is air minus 3. You will never break the window. Okay, when you will slide the window, what you will do? So suppose you slide forward. So here simply when you will slide, this window basically comes here. Okay, and here you left this element, okay, that's minus 2, and you just add minus 3 inside the window. Again you slide forward, simply think, again you slide forward. So here you will just simply add new element. Okay, so you will just add 4 and you left the element 1. Okay, same way you will reach like here, like 3 and 4. Okay, the new element inside this window is 3 and 4. So here size of window is 2. So this is basically technique we used to slide forward, and we will not break the window. And every time when we slide, simply the like the initial element, we will just left that element and we will add the next element inside the window. Okay, and inside this window we are these elements, we simply add each and every element inside the sliding window. Okay, so here if suppose think the size of window is like uh, greater than 2, so I'm just erasing all those things. Suppose the size is less than n minus k, sorry, less than n simply. So here the value of n is 8, so this is basically our window. Yeah, it looks not so good, but think this is our window. I'm just making something. Yes, yeah, that's good. So this is our window. Okay, so how can we slide that? So you can slide it this way, you will reach there. I'm just making same as the previous one. Okay, so this is our window. Okay, simply. So right now you can ask me that, understand, I understand what is slidey window concept, I understand we will not break the window, and we will slide it, we will left the previous element, and we will. Now you can ask me that how can we solve this problem? Okay, you tell me that this is a sliding window concept. So simply what we actually do, we first, I'm just again erase all the links. So what we actually do, suppose here, since we have to solve this problem. So here what we will do, we will first calculate initially the sum, that is the subarray sum inside the first window. So our first window is minus 2 and 1, think simply. So here the sum is simply, what is the sum? So it is minus of 1. When we add minus 2 with 1, it gives minus of 1. Then after we will slide our window. Okay, I'm using another color or another pen, you can think. So I am sliding this window in this way, we will reach there. So here what we will do, we will simply when we slide it, so our main purpose is the sub array sum. So here what we will do, we will first add minus 3 with minus 1, it simply gives the minus of 4. And we simply subtract the this value, that is the first value. So here it simply gives minus of 2. So our new subarray sum is minus of 2. Same way when we slide further our window, so we will cover this element 4 and we will left our element 1. So here our subarray sum is simply 1. Same way we will calculate and we will reach there. Okay, and there we will calculate that our subarray sum is 7. Okay, okay, I'm just filling all the. So here you can see that all the subarrays, all the windows and their sum. Okay, and this is kind of local maximum. Like in our previous problem, we assume that the subarray sum is local maximum and the actual sum we want to find, which is maximum, is our global sum. So I'm just going to write there local and there this is our local maximum. So among those we will find which is the maximum local maximum, or you can say that maximum sum array sum. So it is simple right now. We can easily see this 9 is maximum and here this 9 is our global maximum. Okay, and this is basically the answer of this problem. Okay, so find we find our global maximum. Now you can ask me what is the time complexity. So it is simply order of n. So it is simply order of n time. Okay, so hope you understand what is sliding window concept. Okay, and how can we solve this problem using sliding window concept. Also you can solve this problem using prefix sum technique. So we already covered the prefix sum technique in our previous lectures, so you can try this by your own. Also you can use this concept too. So here this is our solution. Okay, let's understand step by step. So you understand first what is the problem. This is basically our problem and this is the problem, like solution, simply a sliding window technique, and this is our code. Okay, so here we will understand line by line. So I used to write the function as public. Okay, and every time I'm using like Java programming. If you are using another programming language, that is fine, because this is basically a data structures and algorithm lectures, so you can understand the technique and you can solve this problem by your own. So right now this is our function and I used to make it public, and return type is int. Why? Because we have to return the maximum sum. And I used to write the function name as max sum, because in the last problem it was max sub array sum. Right now here I'm passing the array nums. Nums is basically our array. Okay, and here I'm not gonna pass the array size, because we can easily calculate in Java nums dot length, and this k is simply the sub array size, that is k. We have to find the maximum sum. So simply we declared the current sum as a local maximum. Understand in this way, this is our local maximum. And what we will do, we will first calculate the sum, that is the current sum up to k. We will add just all elements. So here in the first part we will first add this minus 1. Okay, that is our current sum, and we make it that this is our maximum sum, because we don't know what is our maximum, so we just made it that this current sum is our maximum sum, that is our global maximum. And right now we will start another for loop, and this for loop basically calculate the maximum sum. And this is very important, that from where we will start our for loop. So we will start with I is equal to k. Why? Because we already calculated up to k. So you can see there we can easily calculate it, like we already calculated up to minus 2 to 1. Okay, so here we will not start with minus 1, we will start after that. Okay, so we want to calculate this sub array 1 minus of 3. So we will start with index 1. So here you can see that. So here you can see what we actually do. Understand. So I'm just going to erase all the things. Okay, so understand, we will. Okay, so here we already calculated up to this part as a current sum. This is our local maximum, and we will start another for loop. Okay, so basically the separate for loop from minus 3. Okay, and what we actually do, we already calculated the local maximum, guys. Okay, this is our local maximum. I just used to write L. Okay, 1 minute. So this is our local maximum, and we will start the for loop from this index. Okay, and here we will simply add this number, this current index value, that is minus 3, for with what, with local maximum. Okay, I'm just adding 3 with local maximum, and we will subtract the first value, that is minus of 2. Okay, we will subtract this minus 2 with local maximum. So you can say that this is our value which we want to subtract, and we will add this 3. So it basically gives you minus of 2. So here you can see that we will start our for loop with value k, and here we will just add which value we want to add in the current sim. We will add the current value, that is nums of I, and we will subtract nums of I minus of k, and I minus of k is simply here, this is minus 2. Okay, so in this situation, so this is our local maximum. So in this way we can calculate our local maximum, and and here we will calculate our global maximum, that is maximum. So if maximum, that is we already calculated it, if greater than the local maximum, that is the current sum, that means we will not update it. And if this current sum, okay, that is the local maximum, if it is greater than the previously calculated global maximum, that is the maximum, that means we will update this maximum simply, and in this way we will find our global maximum, that is maximum. So in this way we can calculate the maximum subarrays of size k using sliding window concept. Okay, and the time complexity is order of n time. So this is basically our today's problem, guys. So we almost cover all the problem of sum, like subarray sum. Okay, and subarray sum of size k, maximum subarray sum. Also you can using this technique you can find a minimum subarray sum of size k. So it is very simple, you can just little bit think, and this is kind of variation of this technique, very simple, you can try with your own. Okay, and thanks for watching, and if you like the video on lead code coding interview series, please do subscribe the channel. So here we will solve 450 plus question, okay, on each and every technique, and we will tell you, we will solve all kind of algorithms which basically used to ask in various company interviews. Okay, also after completing this lead code series we will make a separate lecture on data structures algorithms, where we will discuss first the theory of, suppose someone wants to learn array. So we will first discuss what is an array, and we will explain how can we declare array in Java, in C, in C++, in Python, C Sharp, every language. And after that we will put this link that we can solve this problem of these algorithms using this technique there. So just stay continue with us. Also we will make a separate lecture, suppose someone wants to learn what are the in a single video, what are the Java 8 features, what is the collection framework, someone wants to learn like full stack, what is the roadmap of become a full stack developer, so all kind of problems. So we will like do everything on this channel step by step. So just stay continue with us, and please do subscribe the channel. Thanks for watching, and this is Atul Kumar signing off.